Alright folks, slightly shorter podcast on dilutions. Right? We often think about diluting things. We might be diluting tomato soup, we might be diluting orange juice. Think about how you prepare tomato soup. You add a can of water. What happens to the concentration? Well, if you take 1 can of soup and you add to it 1 can of water, you'd think that it was about half the concentration that you started with, right? That makes sense. What happens if you take orange juice? With orange juice, you add 3 cans of water. What do you think happens? Well, that's kind of, if you think about it, the orange juice is 1 can out of a total of 4 cans, so you'd think that your concentration would be about 1/4 of what you started with. By the way, folks, you'd be right. So what we're going to do is try and figure out how to do that mathematically. Now, we do have an equation for molarity, and it's moles of solute per liters of solution, but let's solve for moles of solute. So moles of solute is going to be molarity times your volume is going to be equal to your moles of solute. Now, what happens when we went and we took our tomato soup and we added a can of water? Did we change the amount of soup that was in there, the amount of tomatoes that was in there? No, the moles stayed the same. What happened when we made our orange juice? Did we change the number of moles of orange juice that were there? No, we didn't. So, if this is our initial system, our moles hasn't changed, so it's equal to our final set of molarity times volume. So our volume went up and our molarity would go down. And that would make perfect sense. So, let's try this. Let's say we have 300 milliliters of tomato soup, and let's assume that its molarity is 1, because we don't know what better, just pick a number, right? And our volume is changing to 600 milliliters. So what's happening to our molarity? Well, if we solve for M2, we get 1 times 300 divided by 600, and that's equal to 0.5, which is 1/2, which is exactly what we expected the molarity of the soup to be. Is half of what it started. What happens if we do the orange juice? Well, let's say we have 350 milliliters of the orange juice, which is really what we have, and our molarity is, let's make up a number of 10, right? And we're trying to figure out what our molarity is. Now, our volume goes up to 1.4 liters. Now, we can't put a 1.4 here because we have to make sure our units match. And since we used milliliters over here on the left, we're going to change this to 1,400 milliliters. So we'll put 1,400 up here for our volume. And we're going to solve for M2. So that's 10 times 350, which is 3,500, divided by 1,400. And that gives us a number of 2.5 molar, which is 1/4 of 10, which is what we expected. So, all right, let's take that into the realm of chemistry. So let's see if you can solve this problem given the information that you're given. So pause the video if you would, please, and see if you can solve it. All right, so we have 35.9 milliliters, 35.9 milliliters of a 3.0 molar stock solution. And we want to have 2 liters of it. Oops, notice I've got milliliters over here. So I'm going to have to convert this to 2,000 milliliters. So that's 2,000 milliliters. All right, and I'm trying to solve for my new molarity. So all I have to do is take 3.0, multiply by 35.9, divide by 2,000. My milliliters cancel. I'm left with molarity, and the molarity of this solution is going to be 0.054 molar. All right, try this one, see what you come up with. All right, we have 180 milliliters, that's 180 milliliters of a 6 molar stock solution, and we're diluting it to 0.5, no, this is liters, not milliliters, so that's 500 milliliters. So that one's 500 milliliters. So I can now go, because now I can get rid of my milliliters, and I'll be left with molarity, which is good. So I have 6, let's try that again, 6 times 180 divided by 500, and if I do the math there, I will get 2.16 molar. Now guys, I am keeping too many sig figs here. I'm not worried about that. I just want to make sure you understand what you're going to see on your calculator. Right. Now remember, we talked about proper dilution technique in the last podcast. Right. In this particular case, what you would have done was you would have taken 180 milliliters. That's what you started with up here. All right, and you're diluting to half a liter. So you'd put your first 180 milliliters down here in the bottom of the volumetric flask. Down, it looks like this. There wouldn't be any solid in it. It would just be 180 milliliters of stuff. And assuming this is a 500 milliliter volumetric flask, you would fill it right up to that line, making sure that you get right up to that meniscus. Okay? And you'd just be adding distilled water. Now, in reality, we have a much more common problem. A more common problem is in the lab, you need a particular concentration of solution. So, for example, I might need to prepare 100 milliliters of a 2 molar solution of hydrochloric acid. Now, I might not have any 2 molar solution, but I might have 6 molar on hand. All right. So if I've got 6 molar solution on hand, and I want to produce 2 molar, and I want to produce 100 milliliters of it, the question is, how many milliliters of 6 molar hydrochloric acid do I need? Well, clearly I need less than 100 milliliters, but how much less? Well, if I'm trying to solve for this, I divide both sides by 6. So I have 2 times 100, okay, that's 200, and I divide by 6. When I take 200 and divide by 6, I get 33.3 milliliters of my 6 molar stock solution that I need to be able to make the more dilute one. All right, go ahead and see if you can do this one. This is the last one we got. Pause the video, see if you can do it. All right, I'm making 250 milliliters of solution, and it's 0.5 molar, and I've got 12 molar on hand. So I take 0.5, and I divide by 250, and multiply by 250, divide by 12. I'm going to end up with milliliters as my final answer. And when I do this, my answer to that problem is 10.42 milliliters. And guys, again, I'm keeping way too many sig figs, but I'm doing it simply so that you see what you get on your calculator. Okay? That's it, folks. We're done. Go ahead and do your worksheet, see what you come up with. And if you have questions, please ask us in class. We'll see you then. Bye.